This is the video on speed. So remember, in these videos, there are codes in the video. There are two codes. One will be a written code that will pop up on the screen. The other code will be a verbal code said by myself. Each code is 3 numbers. You will need all the codes in order to move on with the homework assignment. So remember, when you're looking at the slide or watching the videos, some of the text is in green. Those are the big ideas, the key concepts that should be written down in a notebook if you're taking notes. So this is the written code. I would recommend you write this down somewhere. All right. So let's just go over speed, right? So speed is the distance an object travels per unit time, the rate of change of position. So you can see here I do have an equation off to the side, but I also have this triangle. This triangle will help us determine what equation we're going to use when we're calculating problems. So we'll get to that later, but you can see here the equation for speed equals distance divided by time. Now, it is a scalar quantity. It only has magnitude. That's just the amount or the number. So the direction of the object does not matter. Now, here are some units of distance per unit time. So we have meters per second. So in physics, we use meters per second a lot. If you're driving in America, you have miles per hour. That's going to be what's on the speedometer and like on speed limit signs. If you're in other countries, the cars and the speed limits are in kilometers per hour. You can also have something like centimeters per year. If I'm measuring the speed of how fast a glacier travels, I probably want to use something like centimeters per year or continental drift, something like that. It's a really slow rate of speed. So now let's talk about the difference between speed and velocity. So these words have probably been used interchangeably, but in science, there is a key difference. So velocity is how fast and which direction. So it's measured the same way as speed and has the same unit. So meters per second, kilometers per hour, except it is a vector quantity. So a vector has both magnitude and direction. So you can see here off to the right, well, if I'm just saying how fast something's going, what is the speed? The speed's going to be the same no matter what direction travels, but velocity, well, you can see, well, if it's going one direction, it's, most of the time, like direction, we think of left, right, east, west, north, south. So those could be directions, but when we're doing math and we're calculating things, usually that is a positive or negative. So we need to keep that in track when we're doing problems. That'll come up later in the future problems. But now let's just get practice calculating speed. So here's a question here. Becky leaves home and rides a distance of 30 kilometers. It took her 2.5 hours. What is her speed? So the first thing I need to do is ask myself, what is this question asking me to find? It's asking me to find the speed. So here's how I use that triangle. I cover up the unit that I'm looking for, which is speed, and that gives me the equation. So if I cover up speed, I get distance divided by time. So what I do is I plug in what I know. I know the distance is 30 kilometers and the time is 2.5 hours. So I plug everything into a calculator. I get speed equals 30 kilometers divided by 2.5 hours, and you're going to get 12 kilometers per hour. So now let's do another problem. So here's a question. A speedboat is traveling at 100 kilometers per hour. How many hours will it take the boat to travel 115 kilometers? So now I have to ask myself, well, what is this question asking me to find? It's asking me how many hours, which is a unit of time. So I cover up time and I get distance divided by speed. So you can see here, well, I just take the distance, which is 115 kilometers, divided by the speed, which is 100 kilometers per hour, and you get 1.15 hours. So at this time, I'll go ahead and give you that verbal code. The verbal code is 380. I say that again, the verbal code is 380. All right, so let's do problem number 3. A hot air balloon traveled 2.5 hours at a speed of 4 kilometers per hour. What distance did it travel? So in this one, it's asking us to find the distance. So you can see here, I just cover up the distance, and this one is speed times time. So the speed is 4 kilometers per hour, and the time is 2.5 hours. And the answer is 10 kilometers. So those are the 3 kind of problems you can have. Yeah, the numbers can change, the units can change, but that's it. You either can calculate speed, distance, or time. So So you can see here, like there was this, we did do a class activity. This was speed calculations, when we got practice calculating speed, distance, and time. Well, now let's answer this question. How can the speed of an object be measured? So we did this lab, and it's called the wind-up toy. So what we did was we took a wind-up toy, we wound it up, and we set it next to a meter stick, and we measured how far that object traveled, and we timed how long it took. Now, using the distance and using the time, what we did was we were able to calculate the speed of that wind-up toy. Now, if we know the speed, then we could calculate, well, how long would it take to go this far? And if we know speed, like, hey, if I set this wind-up toy going, like let it loose for 60 seconds, how far would it travel? Right. So it's a real simple lab to do, but it covers the topic of speed. So once again, I'll just leave you with this final thought. Remember, there's too much unknown in the universe to take a break from learning. Get out there and question everything.